In this video, we're going to review binary acids. We're going to see how to name the binary acids and also how to write formulas for binary acids. Binary acids, as you can see in the name, bi contains two elements only. You have hydrogen and then typically a non-metal after. So an example is HCl, hydrogen and chlorine. And if it's an acid, you have to put AQ, that means aqueous, dissolved in water. If you put HCl gas, that is not the acid. For reasons that you'll learn later, the acid has to be AQ. So binary HCl, AQ. This over here, HI, AQ is a binary acid. Two elements only, H and the nonmetal I. And you have to put AQ next to it. There are other acids that you'll learn later on called oxyacids. These are acids that contain a polyatomic ion. So they're hydrogen with a polyatomic ion. For example, HClO3AQ. This is an oxyacid. It is a polyatomic ion that contains oxygen, but it is not a binary acid because there's more than two elements there. It is an oxyacid because it has the polyatomic ion with the oxygen in there. Another one is HiO3AQ. This is an example of an oxyacid, not a binary acid. Here's another binary acid, H2SAQ. And over here, we have H2SO4AQ. This is an oxyacid. So if you can distinguish between binary acids and oxyacids by looking at their formulas, that's a good first step. Now we'll go take a look at how to name binary acids. So we'll start with HCl. Firstly, you need to identify that HCl is a binary acid. To name it, you would start off by putting the prefix hydro. All binary acids start with hydro. Then you're going to name the nonmetal that's there, chlorine, but change the ending from I-N-E to I-C-E. So we have hydrochlorine becomes chloric, hydrochloric, and then space the word acid, hydrochloric acid. Let's try to name HiAQ. We have HI. HI is a binary acid, so we'll use the prefix hydro. Iodine, change the I-N-E to I-C. So hydro, iodic, and then space acid to indicate that it's an acid. We can try to name H2S AQ. Recognize it's a binary acid because you have hydrogen and a non-metal next to it. And so here we get, and there's AQ. We have binary, so we're going to put the hydro in the front. The sulfur becomes sulfuric, hydrosulfuric, and then acid. If you want to write a formula from the name, it's very similar to how you would write it for ionic compounds. So suppose I had hydrofluoric acid. First, I need to recognize this is a binary acid from the name. And I know that because only binary acids are going to have the prefix hydro in them. The oxyacids will not, and we'll see that shortly. So hydrofluoric acid is a binary acid because of hydro. And so what I do is I know that starts with an H. And then if you look at fluoric, that comes from fluorine. So it's an F. H is +1, F is -1. And then you can just crisscross and you get H -1, F +1. Drop the charges and the 1 and 1 because you don't need that, and you get HF. Now to really finalize this, to indicate it's an acid, you can put a Q next to it. So that is HFAQ. If you don't put the AQ, you don't have the name, or you don't have the formula for the acid 100% correct. You really need to indicate the AQ portion. Let's try one more example here. Hydrobromic acid. Hydrobromic acid. So firstly, you need to recognize it is a binary acid because of the hydro in the front. So we're going to put H. The nonmetal there is bromine from Bromic, +1, -1. Hydrogen's always +1, so you don't really have to worry about changing that up. Do your crisscross, and you'll get H -1, Br +1. Drop the charges in the 1, and you get HBr. Don't forget to put your AQ just to finalize, and there's hydrobromic acid. So far in this video, we saw how to distinguish between binary acids and oxyacids. We saw that for binary acids, if you have their formula and you want to go to a name, you have to start with the prefix hydro, then you go with the non-metal naming name and change it to IC instead of IDE. And if you have the formula and you want the name and you want to go to a formula, you first of all identify its binary by seeing hydro in the front. And then you set up your elements. So hydrogen would come first, fluorine or whatever the element is would come after, put their appropriate charges, crisscross, drop the charges, simplify if you need to, and then you have your AQ at the very end. So these were some examples of naming and writing formulas for binary ionic compounds. In the next video, we're going to name and write formulas for the oxyacids.